So here's one of those theoretically easy questions from JEE Advanced 2020 Physics Paper 2, and it says that in an X-ray tube, the electrons emitted from a filament, that is the cathode, carrying current I, hit a target anode at a distance d from the cathode. The target is kept at a potential V higher than the cathode, resulting in an emission of continuous and characteristic X-rays. If the filament current I is decreased to I by 2, the potential difference V is increased to 2V, and the separation D is reduced to D by 2. Then, so it talks about the cutoff wavelength, whether it reduces to half or not, the wavelength of the characteristic X-rays, what happens to them, and then about the intensity of all the X-rays. So let's think about it for a moment. First of all, right off the bat, the word characteristic X-rays, well, this word has a character. And that character is that it is characteristic for a single type of a target. So if you put in zinc, no matter what you do, the K alpha, the K beta, the L alpha, the L beta, all these lines will be same regardless within experimental error bounds. So the characteristic X-rays will always, their wavelengths will always remain the same because it's a property of the material itself. It does not really depend on the conditions that you put it in. Its intensities might change, but the type of X-ray it would emit, that won't. So the wavelength of the characteristic X-ray, that will remain same. Next is the cutoff wavelength. So the cutoff wavelength is the smallest wavelength that you can get. And you get the smallest wavelength when you have the highest energy. So remember that there are two ways in which you get X-rays. Those two are listed here: continuous and characteristic X-rays. Continuous X-rays are a result of an electromagnetic radiation when an electron enters near an atom and it decelerates or changes anything regarding its properties, and then it emits off a photon. So the maximum photon energy you can have in continuous X-ray is when the energy is equal to the energy of the electron put in itself. So the maximum energy is just equal to the energy of the electron, the maximum energy that you give to the electron. The maximum energy, well, that is just equal to E times the potential difference you drive it through. And when the potential difference is doubled, the maximum kinetic energy of those electrons is also doubled. And when the maximum kinetic energy that is doubled, the wavelength, remember that wavelength goes inverse to energy. So the cutoff wavelength of the photon that you get, that decreases by half. All right. So the cutoff wavelength will reduce to half, and the wavelengths of the characteristic X-rays will remain the same. This is correct. Next option is cutoff wavelength as well as the wavelengths of the X-rays will remain the same. This is not true. The cutoff wavelength will change. So this is not true. The cutoff wavelength will reduce to half. This is correct. And the intensities of all the X-rays will decrease. Now, here's the thing. Intensities really don't tell you about what type of thing is being emitted. Intensity is basically given a type of wavelength, given a range of wavelength, let's say, how many of those wave trains do you see? It's basically proportional to that. So when you decrease the current to I by 2, there are lesser number of electrons coming out of the filament. And when there are lesser number of electrons coming out of a filament, for a given wavelength, the number of electrons that number of electrons that deliver that kind of energy, that also decreases, simply because the supply has become halved. So the intensities will decrease. Will it be exactly half decrease? Well, we don't know. We can't say for sure. So the intensities will decrease. That is correct. We don't exactly cannot figure out how much it will decrease, or because there are many other factors in that. But this option is correct. The last option is the cutoff wavelength will become 2 times larger. No, energy has doubled. So the wavelength will go half. The frequency will become 2 times, not the wavelength. So this one's wrong. So the correct options are A and C.